This model shows the essential components of a typical steel structure. The steel structure is connected to the footing with a base plate. The base plate having in it hold-down bolts that are cast into the concrete and protrude out for the column and base plate to slot over during the first stage of erection. From the base plate we see the column. The steel column has connected to it a steel beam or rafter. Generally, if it's horizontal, we call it a beam, and if it's on an angle or rate, we call it a rafter. Examining the beams connected to the columns, we have an arrangement of configurations. This connection here can be considered to be a semi-rigid connection. It has an angle seat and a cleat towards the top flange, and it's called semi-rigid because it has partial resistance to rotation of this beam, so that it's being, as well as being supported so that it doesn't settle or fall down, is also resisted partly in rotation. This connection on the side here that has a web cleat, as we call it, and 3 bolts has a greater ability to rotate, so you resist rotation to a lesser extent, and is called a simple connection because there's no rotational fixity. This beam and this rafter are connected to the column with what we call a rigid connection. A rigid connection resists rotation, so that the beam, as well as being supported by the column, has whatever bending is occurring at the intersection between the beam and the column resisted by this connection. And as you can see here, it comprises of a very thick end plate, so the beam has a thick plate welded to its end, and an arrangement of 4 bolts at the top and 4 bolts at the bottom. And as well as that, the column has a web stiffener at the top, the location of the top flange of the beam and the bottom flange of the beam, to prevent the column web from crushing or collapsing due to any rotational action coming from the beam. What you're looking at here is a splice. It's a full moment splice, and the reason why we quite often see full moment splices in steel structures is because the beam may be too long for transportation, so that we transport it in sections and have the splice at a location where the bending moment is relatively small. To this side we have a rafter which resembles a beam, except it's on a rake or an angle, and the way this rafter is connected to the column also incorporates a haunch, which is part of a universal beam that's cut to this sort of profile. And with this haunch welded to the rafter, we in fact have a much deeper section at the intersection between rafter and column, and the end plate is significantly deeper, with the bolts that you can see here spread over greater distance. So there's greater rotational fixity, so this generates a full moment connection. Unfortunately, these are spaced at intervals of some 5 or 6 meters or more, and in order to connect or attach the cladding, whether it be steel sheeting or fibro or some other material, we need to bridge between this frame and its adjacent one with subsidiary members or secondary steel framing, and it typically comprises of purlins, or if it's in the wall there will be rows of girts to which the cladding will attach. So the cladding will attach to this purlin and the next one and the next one, and so forth. This purlin here that you're looking at is called a Z purlin. The reason why is because its shape or profile is the shape of a Z, and with Z purlins, because one leg's slightly different to the other leg, we have the ability to slot them through and lap them. So this is lapped, and at the lap is where we connect the cleat that attaches the purlin to the rafter. This odd body here is called fly bracing. It's typically an angle, a small angle that attaches the bottom flange of the rafter to the purlin, and its purpose is to stabilise the rafter, because what happens during wind uplift, the rafter attempts to lift, and as it lifts, the top is stretched and the bottom is in compression, and it tends to kick sideways or twist, something called lateral torsion or buckling, and to prevent it twisting, these fly braces are attached at various intervals. So to stabilise the rafter will have this fly bracing at every third or fourth purlin location.